Hey guys, this is your review for Unit 2 test. I'm going to go over every single one of these problems. So let's look at the first one. If you need any additional help, you can find the notes in lesson 2.1 to 2.3. All right, so first we're going to graph the set of inequalities. So first we need to put it in slope-intercept form. If you notice, this equation is not. I'm going to rewrite it, and then I'm just going to solve for y. So to solve for y, we need to subtract 1. We get y is less than 2x minus 1, and y is already by itself. So from here, we're going to identify our slope and our y-intercept. So your slope is 2. We want to put it over 1 because it always has to be a ratio or a fraction. And then my b value is my y-intercept, and my y-intercept is at -1. So let's start by plotting our first point at -1. And then the way I'm going to move with my slope, the 1 is always to the right, or the denominator is always to the right. And because my slope is positive, then we're going to go up. So from here, we're going to go right 1 and up 2. Right 1 and up 2. Right 1, up 2. And then you draw as many points as needed. Because this inequality does not have an equal sign, we're going to draw our line dashed. And when we read this inequality, we know that y is less than, and less than means below, so we're going to shade below that line. We're going to do the same thing for the next equation, or inequality. The next inequality is already in slope-intercept form, so all we have to do is identify my m, which is my slope. That's 1 over 3, and then my b, or my y-intercept, is -2. So let's plot our first point at -2, and then we're going to move 3 to the right and 1 up. So 1, 2, 3, 1 up, 1, 2, 3 to the right, 1 up, 1, 2, 3 to the right, and then 1 up. Draw as many points as you want, or as you can, and then this inequality has an equal sign under it, which means that our line is going to be solid. So from here, we're going to draw a solid line through those points. And if we read this inequality, we read it as y is greater or equal to, so we're going to shade above that line. We look for the region where it is double shaded, and it looks like it's this region here. So all my solutions will be part of this region. Remember, if any time it falls on a dashed line, that means it is not a solution. So I'm going to say this point right here is part of my solution set. 6, 0, it's on a solid line, and it's on the double shaded region. Another point would be this one here, where we have 4 and 3. That's another good solution point because it's part of the double shaded region, or the region that both inequalities share. So we've got, sorry, I believe it's actually 4, because your x is 4 and your y is, so it would be at 4, 3. All right, let's look at the next problem. We're writing an equation given the graph. Let's write the equation for the red line first. We want to look at my y-intercept. My b is -2. And then to get to the next point, we are rising 2 and right 1. So we're going 1 to the right and 2 up. So we've got positive. My line is solid, so let's write that down. Solid means that we have an equal sign under the inequality. And because it's shaded below, that means that it is less than. Then we get my slope, which is 2 over 1. We can also write it as just 2. X and then my y-intercept is -2. So this is my equation for the red line. Now let's look at the blue line. The blue line, the y-intercept is at 1. So I'm going to put b is equal to a +1. And then my slope, let's look for another point. Looks like this one here. We're going to go up 2 and to the right 3. So m is 3 to the right and 2 up. Another positive number, so here we have y. And because my line is dashed, there's going to be no equal sign. And it is shaded above the line, which means it's greater than. So then we have my slope, 2/3, put the x attached to the slope, and then my y-intercept is +1. So my two equations are this one and this one. And this will be for the blue. For the next one, we're going to do the same thing. The first equation is not in slope-intercept form, so we're going to rewrite it so it is in slope-intercept form. The only thing that's keeping us from having it in slope-intercept form is this -3. It's attached to the y by multiplication, so we want to divide every number by -3. We get y is less than or equal to, but because we are dividing by a negative number and we have an inequality, that means my inequality is going to switch. So we've got +2/3 because a negative and a negative is a positive, -2 because 6 divided by -3 is -2. Identify my y-intercept is -2. And then my slope is 2/3, 3 to the right and 2 up. Because there's a solid line under it, we're going to draw a solid line. And if we read the inequality, y is greater. So we're going to shade above the line. Let's go ahead and look at the next one. The next one is already in slope-intercept form. So all we have to do is identify my y-intercept, which is -3. And then my m, which is my slope, is -1/2. We're going to go 2 to the right, and that 1 means we're going down 1. So 2 to the right, down 1, 2 to the right, down 1. Because there's no equal sign in that inequality, that means that we are going to draw a dashed line through those points. And when we read it as y is less than, and less means below. So we're going to shade, oops, wrong line, below the line. We look for the double shaded region, which is this one right here. So all my solutions will be in this double shaded region. So let's go ahead and look. Remember, if it falls on a dashed line, that's automatically not a solution. So I'm going to say this point right here, which is at -4, -2, would be part of my solution set. Let's look at the next ones. We're going to be solving systems algebraically. And for this part, if you need a refresher, please go to lesson 2.5. Lesson 2.5 will have the notes for this part. All right, we see a y equals. We're going to put parentheses around what the y, because we saw that it was y equals. Put parentheses around the y on the second equation, and then go back and put parentheses around what y is equal to. So remember, in this little space right here, we're going to write down what y is equal to. So we're going to rewrite negative 3x is equal to negative, there's my parentheses, that's where I put the x plus 5, and then everything else will be the same. And then from here, all we're going to do is solve for x. So notice how there's a 1 here. We're going to distribute that negative 1. So this is negative 1 times x is negative 1x. Negative 1 times 5 is negative 5. Then we bring down everything else is the same. We combine like terms. This gives us negative 4. So negative 3x is equal to negative 1x minus 4. Then we're going to add 1x. And we get negative 2x is equal to, these cancel, negative 4 divided by negative 2, and x is equal to positive 2. So now that we know what x is equal to, my answer, I'm going to put 2 for my x. And now we're going to use the first equation, substitute my x value, and we get y is equal to 7. So when we draw these two lines, their solution is 12, 7. Make sure you use your calculator to double check your answer. Let's look at the next one. The next one is also y equals. We'll put parentheses around the y's, and then what y is equal to. So we're going to rewrite 8x minus 2 times, we're going to enter this for the y, negative 5x plus 7 equals 14. And then we just do the math. And from here, we just solve for x. So we're going to combine like terms. That gives us 18x minus 14. We're going to add 14. Get 18x equals 28 divided by 18. And x is equal to, we can simplify this by dividing it by 2. So we'll get 14 over 9. And now that we found our x value, that's 14 over 9, we're going to substitute that. I'm going to use the second equation. So we've got y is equal to negative 5 times